Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 5.2. Problem statement says, when a liquid or a gas occupies a volume, it may be assumed to fill the volume completely. On the other hand, when solid particles occupy a volume, there are always spaces, voids, among the particles. The porosity or void fraction of a bed of particles is the ratio void volume to total bed volume. The bulk density of the solids is the ratio mass of solids to total bed volume. And the absolute density of the solids has the usual definition, mass of solids per volume of solids. Suppose 600 grams of a crushed ore is placed in a graduated cylinder, filling it to the 184 centimeters cubed level. 100 centimeters cubed of water is then added to the cylinder, whereupon the water level is observed to be at the 233.5 centimeter cubed mark. Calculate the porosity of the dry particle bed, the bulk density of the ore in this bed, and the absolute density of the ore. Okay, I have kind of drawn out pictures of each one of these systems so that you can tell what they're talking about, because sometimes it can be hard to visualize, take the words and put it into a picture form. Okay, so I've done that here to kind of help show you what they're talking about. So we've got our total solid system here. When solid goes into a certain volume, there are void spaces in between the solid particles. Okay, so the box represents the total bed volume. The void volume is all of the yellow space in between here, all the yellow space. The volume of the solids is how much space, how much volume do the actual solids occupy. It's like if you have the total bed volume and you subtracted out all of the solid volume, then you would have the void volume. And if you had the total bed volume and you subtracted out the total void volume, then you would get the total volume of the solids to kind of fill in the volume that way. So total volume of solids plus total void volume equals total bed volume. Okay. The mass of the solids is just, you have the solids, you put them on a scale, they weigh a certain amount, that's the total mass. Okay. So, given that we've got a mass of solids that's 600 grams, the total bed volume right at first would just be, what does it look like in state 1? Well, the total bed volume is 184 centimeters cubed, okay? But then you have a certain amount of water. 100 centimeters cubed of water is poured into this vessel, right? Then you have more volume in state 2. There's a certain amount of water that's above the level of the ore. That is, this much volume, but then you still have all the sand volume underneath as well. Okay, so the total bed volume in the next one is 233.5. Okay, so we need to figure out how much volume is being occupied in the top part, so then we can figure out how much of the water volume is in the bottom part, because if we figure out how much water volume is in the bottom part, that will give us how much was void. So initially the void volume is filled up with air. If we replace all of that air with water, then we can say, the fluid that's in there, if we know how much volume that occupies, how much water we poured in, and we know how much water didn't end up in the void spaces, then we can say, oh, this much water volume ends up in the void spaces. That means we have this much void volume, okay? Okay, so the top part is 233.5. So we say, okay, we have this much water in the top. Okay, so about half of the water is in the top and half of it's in the void volume. Okay, So how much water was in the sand? This is our void volume of water. So the void volume is there. Now we start looking at the bottom part, and we say the total bed volume in state 1 was 184. We knew that the amount of void volume was 50.5. Okay, so how much was our solid volume? Total volume minus void volume equals solid volume. Okay, so that's our solid volume there. The porosity, they asked us what the porosity was, and they gave us the ratio in the problem statement. Porosity is void over total. There you go, that's the porosity. Bulk density, they gave that to us in the problem statement. The mass over the total volume. That's the bulk density. What's the absolute density of the solid? It's the mass of the solid divided by the solid volume. There you go. And that is it for problem number 5.2. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.